So we've got to the stage of the course now where we need to think about communication between our two services, and what we're going to start with in this example coming up is synchronous messaging. And synchronous messaging between our two services, it's not typical really, and we're going to use it for this example, but it's not really what we're going to be using to communicate between our two different services. And let's suppose, for example, that service A over here is our search service and service B is our auction service. This is where we're going to get our data from. Now, how do we do this? Well, synchronous messaging, there's really two types. There's HTTP or gRPC. We're going to cover both of those on this training course, but we're going to start by using HTTP. And that means service A is going to need to make a request to service B. Now, in the synchronous messaging world, that means service A is going to be waiting for a response back from service B. And service B will give it the response, and then service A can carry on with the work it was doing. Now, what we have here is we've created, and by using this approach, we're creating a dependency between service A and service B. And service A cannot function for this particular operation if service B is unavailable for whatever reason. And that really defeats the purpose of microservices by using synchronous messaging in this way, because all of a sudden you've got a problem if your dependent service is not operational. And ideally, when it comes to microservices, you would want service A to be independent of service B and can carry on functioning and doing its work regardless of whether or not service B is available. So it's not something we would typically use in the microservices world, but we are going to be using it on this occasion. And you may find other occasions where this is necessary. It's not a law that says you cannot use synchronous messaging. It's just something that you would need to think about and ask yourself, why am I doing it this way? Possibly, if you find yourself reaching for synchronous messaging, then service A should not be a separate service from service B. Perhaps service B actually belongs in service A so that you do not have the synchronous messaging between the two different services. And if you look at our application we're building now, where service A is our search service, then you could argue, why isn't service A doing the search? And for our fictional scenario, I'm going to pretend that the search service is actually something bigger, like Elasticsearch, something that needs to send out crawlers into the rest of our application and start indexing things, and maybe it's a bigger service than it is. But because we don't have crawling technology in MongoDB and the way that we're setting this up, we do need to go and get the data from the auction service in this case. So another downside of synchronous messaging is that service A, in this case the search service, is going to need to know the address of service B. That's fine. We've only got two services just now, but imagine if we had 100 addresses then, or 100 services, then we would need to have many addresses in our configuration full of different services that are going to communicate with each other. And the overhead and management of that would be quite significant. There are technologies that help, like service discovery, but it's not something we're covering in this course. So we are going to be using configuration to provide the address of where service B is in this case. And like I mentioned, there's two options for this. We can use HTTP or we can use gRPC. And we're going to go for HTTP. Now, I say HTTP is a synchronous messaging type of communication. And maybe you're thinking that HTTP is an asynchronous type of communication because of how we've written our code in the auction controller, for example. We've got an async keyword here, which suggests that this code is asynchronous. So if we make an HTTP request to this particular endpoint, how can that be synchronous? Well, this async keyword here doesn't really apply to external communication. So if I'm on a client browser and I make a request to this endpoint, I'm going to make an HTTP request and I'm going to wait for the HTTP response. Internally for this method though, where it's asynchronous, Internally, this is going to delegate this request to go and get the auctions to a separate thread, and it's not going to wait for the response. And that makes it asynchronous. When the response does come back, then the thread that this action is operating on will notify the thread that originated the request that it's complete, and then the original request will pick it up and send out the response. But the client that's made the original request to get this auction ID, that client is waiting for the response, so in that case it is synchronous. So in the messaging world, the client has to wait for the response, or the service has to wait for the response, so in that case it's considered to be synchronous. So there are some cons to using synchronous code in a microservice. And sometimes this kind of design, where you have two services that have a dependency with each other because of the synchronous communication, sometimes it will be referred to as a distributed monolith. In other words, you've got two different services that are dependent on each other, and other than the fact they're not sharing the same database, they pretty much are equivalent to a monolith as we are creating that dependency. Also, imagine if we had service C and service B needed to get data from service C in order to service the request from service A. This kind of thing can lead to dependency chains, and all of a sudden, if you've got an issue with service B, for example, then all of a sudden you've got all sorts of problems because of the dependency chains you've introduced into your application. So we're going to look at an example of synchronous communication on this training course. Are there other approaches we could have taken for this example? Yes, of course there is, but we need to look at various aspects of microservices, so I'm including it in this particular example coming up. Pretty simple to implement, and it gives us an opportunity to look at how we can use it and make it fairly resilient at the same time. We're also going to take a look at asynchronous communication, not in this section, no, that one's coming up, but it does have several advantages over synchronous communication in microservices, in the fact that service A needs to know nothing about service B. The service A will send a message to the service bus. That's all that service A needs to know about. Where to send the messages, it doesn't know anything about service B. There's a brick wall between them. It just doesn't know anything at all about service B, and service B will go and pick up the message from the service bus without knowing anything about service A or where the message originated from. And I'm not going to go into detail now because we've got a whole section on asynchronous communication coming up, but I just wanted to give a little taster because we're going to focus on messaging now. And in the initial instance, we're going to focus on synchronous, which is coming up next.